Hello everyone, welcome to Wallah. So we are going to start transmission line theory, lecture number 6. In this lectures we are going to discuss question discussion we are going to do. So the question discussion will be held on this lecture, transmission line theory. Okay, so in previous class what we have studied? In previous class we have studied impedance, short circuit, open circuit, series resonance, parallel resonance. These all topics we have covered in previous class. And parallel resonance. So today we are going to discuss question discussion only of previous class. So we are going to discuss, we are going through the question discussion part. Okay, this is the first question. They have asked what is the value of propagation constant. So propagation constant value we have to calculate. What is the value of propagation constant here? We have studied in the previous class, in the first class or second class, that propagation constant will be r plus j omega l under root y into z, or under root y is z is r plus j omega l, and this one is g plus j omega c. So this is the value of propagation constant. So our answer will be A. Our answer will be A. Propagation constant will be this one. Then they have said that a transmission line has characteristic impedance Z0, okay, of 600 ohm and length is 500 meter. If it is cut into half, the characteristic impedance of each half. So we have a transmission line having length 500 meter, okay, having length 500 meter, and the transmission line is cut into two parts. That means 250 meters and 250 meters. Then it is asked what is the value of characteristic impedance. So value of characteristic impedance is here 600 ohm, and here also characteristic impedance will be 600 ohm only. Why? Because characteristic impedance does not depend on the length of the transmission line. Z0 does not depends upon the length of the transmission line. It depends upon shape and the medium. It depends upon the shape and medium. It is function of sigma c, sigma d, mu, epsilon and dimension, so that it is dependent. But it is does not depends upon Z0 does not depends upon length. It does not depends upon length. It depends upon shape plus medium, which type of shape you are using that in that case, and medium, which types of medium you are using, and plus frequency also. They have frequency also. Omega is there, so they have frequency also. Okay, so it does not depends upon the length. So characteristic impedance will be Z0 only. Characteristic impedance only Z0 only. A transmission line has a 3 GHz microwave frequency system over a distance of 130 dB. If the frequency is now double, the transmission line loss will be. So they are saying that the transmission line loss they are asking. So we know that transmission line loss is depends upon frequency square, a square of frequency, transmission line loss depends upon a square of frequency. That means loss is due to inertia. So due to inertia, I have taught you due to inertia and due to minority charge there will be loss. So due to inertia in dielectric, due to inertia, so due to inertia loss is directly proportional to F square. So I will say loss 1 upon loss 2 is equal to F1 upon F2 whole square. Yes sir. And the loss is given in terms of power. If it is not given something, so I will take it as a power. So in case of power, it will be in dB, it will be 10 log 10 loss 1 and 10 log 10 loss 2 and 20 log or 10 log 10 F2 upon F1 whole square. Okay sir. So this is the formula for loss. So loss 1 is 130 dB. Loss 1 is 130 dB. So this is F1 upon F2. Loss 1 is 130 dB. Loss 2 we don't know. Loss 2 in dB we don't know. And what is frequency F2? So F2 is 2 times of F1. So 20 log F1 and F2 is 2 times of F1. So it is minus 3 dB. Minus 6 dB, sorry. Minus 6 dB. So loss 2 will be, loss 2 in dB will be, it will be 136 plus 6, 136 dB. So you can calculate easily. Minus 1 by 2, it is 0.3, and 1 by 2 log 2 is 0.3 into 20.6, and it is 1 by 2, so it is minus 6. Loss 1 is given, loss 2 we are calculating. So it is very easy to calculate. So answer will be 136 dB. A option is correct. Answer is 136 dB. A option is correct. Next question. Next question we have, what we have? We have, the question is of ECE and gate both. So I am going to discuss both question, ECE and gate. Consider the following. Characteristic impedance of transmission line can increase with increase in. So characteristic impedance they are asking. So you know that the formula of characteristic impedance. Characteristic impedance is R plus j omega L and G plus j omega C. So it will be R plus j omega L and G plus j omega C. If I will increase resistance per unit length, yes sir, so resistance per unit length is increased, Z0 will be increased, inductance will increase, then Z0 will increase, conductance will decrease, then Z0 will increase, and then after capacitance will decrease, Z0 will increase, and frequency, so we cannot comment on frequency, so this is only things. So resistance per unit length increase, they are saying increase in resistance per unit length, correct. Conductance increase, no. Capacitance increase, no. And increase in inductance, yes. So increase in resistance and increase in the inductance is allowed for increase in characteristic impedance. So our option is C. It is a very easy question we are doing. Next question, I have taught you the formula of Z. In class I have taught you the formula of Z, V0 plus upon I0 plus, minus times of V0 minus upon I0 minus, and gamma upon G plus j omega C, and I have taught R plus j omega L upon gamma, and I have taught under root R plus j omega L divided by G plus j omega C. So this is the question, you can read it out and you know the formula, so you can go use that formula and you will solve this. A transmission line has a RLGC distributed parameters, okay, resistance per unit length, inductance per unit length, conductance per unit length, and capacitance per unit length. Gamma is the propagation constant. Yes, okay. So which expression give the characteristic impedance of the transmission line? So gamma r plus j omega l upon gamma is z naught. So it will be 1 by z naught. R plus j omega l upon gamma is z naught, and g plus g gamma upon g plus j omega c is z naught. So it is 1 by z naught, and r plus j omega l g plus j omega c is z naught. So opposite will be 1 by z naught. So our answer will be B. B option is correct. So we can go through and we can say that B option is correct. So we can relate the formula of characteristic impedance and we can solve this. Next, in lossy transmission line, characteristic impedance depends upon. So in lossy transmission line, so Z0 is equal to R plus j omega L. Z0 is equal to R plus j omega L, G plus j omega C. Okay. Then operating frequency of the transmission line. Does not they are asking operating frequency, they are adjusting. Conductivity of conductor R. R is function of RS, and RS will be under root omega mu upon 2 sigma C. So as RS depends upon sigma C and as R depend upon RS, so it depends upon conductivity of conductor. Conductivity of dielectric G. G is equal to sigma D upon epsilon into C. So as sigma D depends upon G, so G depends upon sigma D, so Z0 depends upon sigma D. Yes. Length of the transmission line, no, there is no relationship between Z0 and length of the transmission line. So we can say that the D is independent from the length of the transmission line. Frequency, it depends. Conductivity of conductor, that means R, it depends. Conductivity of dielectric, that means G, it depends. So our answer will be which part? Our answer will be D. D part. Next question we have that they are asking tangent loss. You should know the what is tangent loss, then we can say that what is going on. A coaxial cable is made up of two brass conductor. The spacing between conductor is filled with Teflon. Means the spacing between the conductor is filled with Teflon. That means dielectric is used is Teflon. Which of the following circuit? They have given the so many circuit. So we have to analyze that circuit, and then we can say that which circuit will represent that things. So first of all, it is made up of brass. First of all, you should have to think over that. It is made up of brass or copper. It is a good conductor. That means sigma C is very high. And sigma C is very high, so RS will be very low. Omega mu upon 2 sigma C, it will be very low. And RS is very low, that means R will be very low. So loss will be very low. So we can say that R will be very low, but it not will be 0. In case of tangent loss is 0. That means in case of dielectric, so dielectric sigma upon omega epsilon will be 0. That means sigma D is 0. So you will ask how you are getting tangent loss sigma D upon omega epsilon. You will study in wave, electromagnetic wave. You will study tangent loss is equal to sigma D upon omega epsilon or sigma C upon omega epsilon. Since it is given for dielectric, so I will use conductivity of for dielectric, epsilon for dielectric. If it is given for conductor, I will take conductivity and epsilon for conductor. So here sigma D is omega upon sigma D upon omega epsilon. For dielectric, it is 0. So we can say that as sigma D is 0. Since sigma D is 0, we can say that G is equal to sigma D upon epsilon into C, it is equal to 0. So G is 0. R is non-zero. So we have three types of circuit. So we have three types of circuit. One is T network, second is pi network, and third is our L network. In case of T network, R, L, but G is 0, so only C will be there. C into delta Z, L into delta Z, and R into delta Z, and R by 2, L by 2, and here L into delta Z divided by 2, R into delta Z divided by 2. So this is the circuit for which part? Pi network. If it is pi network, in case of pi network, it is R and L. So R into delta Z and L into delta Z, and there is a capacitance C into delta Z. C is C by 2. C is C by 2. So C by 2 into delta Z. Here also C by 2 into delta Z. Okay. Because Z is 0, so I will take it as a open circuit. In case of L network, R into delta Z and C into delta Z, L into delta Z, and G is 0, so only C part, C will be there, so C into delta Z, C into delta Z. So they are asking which types of diagrams it is representing. So it will represent this type of diagram. In this case, what you are seeing here, here it is G, it should be not present, so this option is wrong. Here there is no G, so this option is correct. In this case, here there will be G and R will be 0, so it is not correct. So here R and Z both are present, so it is also not correct. So our answer will be B, because G will be 0, because conductance will be 0. Next question. A coaxial capacitor of inner radius 1 mm and outer radius 5 mm, and the capacitance will be something. So what is the formula for capacitance in coaxial transmission line? In coaxial transmission line, the formula for capacitance will be, in coaxial transmission line, the formula for capacitance. You should remember the formula of capacitance, inductance, conductance, and resistance for three types of transmission line: parallel plate transmission line, coaxial transmission line, two-wire transmission line. I have taught you very well. So capacitance per unit length for coaxial transmission line will be 2 pi epsilon into L B by A. This is in farad. So this is in farad. I will not take L because it is given per unit length to farad per meter. And what is the value of B? B here, the outer radius and inner radius it is given. So this one is the value of B and this one is the value of A. So our B by A is given 5 by 1. That means 5. Okay. So this one is capacitance 1. So this is B1 and A1. B1 and A1. Second thing. In second case, what they have asked? They have asked the ratio of outer radius upon inner radius is double. That means B2 upon A2 is double, is 2 times of B1 upon A1. So B1 upon A1 is 5, so it will be 10. Then it is asking what is the capacitance per unit length. That means C2 will be what? C2 2 pi epsilon ln B2 by A1, B2 by A2. So we can use this formula to solve this. So we know that C2 upon C1, we know the ratio, this one will be cancelled out, so we can find out C2 upon C1. C2 upon C1 will be ln B1 upon A1 and ln B2 upon A2, because 2 pi epsilon will be cancelled out. B1 upon A1 is 5 and B2 upon A2 is 10. C1 we know that, so C2 will be 172 ln 5 divided by ln 10. You can solve this and you will get the value. You can solve this and you will get the value. (172) ln 5 divided by ln 10. 120.22. So our answer will be 120.228 means 23. 22 you can write. Picofarad per meter. So answer will be 120.22 picofarad per meter. So this one is the coaxial one, is filled up with 1 and 2 different dielectric epsilon R1 and epsilon R2. The ratio of wavelength. So as we have studied, wavelength in case of lossless and distortionless, or lossy or distortionless, lambda is directly proportional to lambda naught upon under root epsilon r. So I will ask what is lambda 2 upon lambda 1. So you can say that epsilon r2 upon epsilon r1, because they are inversely related. So they are inversely related. So under root epsilon r2 upon epsilon r1. It is a very easy question. I have taught you the formula of lambda in lossless and distortionless and lossy and distortionless. So in both cases you know the formula of lambda. Then capacitance per unit length and characteristic per unit length, lossless transmission line. So lossless transmission line, it is given C and Z0. So C is capacitance per unit length and Z0 is impedance per unit length. Impedance. So for lossless transmission line, Z0 is L into C. Okay, L by C. Phase velocity, as we have studied, phase velocity is 1 by under root LC, where phase velocity is 1 by under root LC, and they are asking what is phase velocity. They are asking what is phase velocity. I'll multiply, then LL will be cancelled out. So Z0 into Vp, Z0 into Vp is equal to 1 by C. So Vp is equal to 1 by C into Z0. So this is the formula of Z0. This is the formula of Z0. So our answer will be B. We know the formula of Z0 in lossless transmission line. We know the formula of Vp in the lossless transmission line. So it is a very easy question to solve. Next, transmission line distortionless condition, LGTB is made up of RC circuit. Like that I have studied, I have remembered. So LGTB is made up of RC circuit. So our answer is C. LG is equal to RC. You can also remember by time constant also. You can also remember by time constant. This is R, this is L. So time constant of RL is equal to L by R. And time constant for RC circuit is how? So RC circuit is time constant RC, R into C, but here R is G, so C by G. R into C, but C, here resistance is not given, conductance is given. Then equate RL circuit and RC circuit. So you will get L by R is equal to C by G. That means LG is equal to RC. So you can use this formula, LG is equal to RC. So our answer will be C. Our C option will be correct. Then transmission line has characteristic impedance for distortionless transmission line. So transmission line characteristic impedance and alpha is given and Z0 is given. So it is lossy and distortionless. Why it is lossy? Because alpha is non-zero. So lossy and distortionless. So in case of lossy and distortionless, alpha is equal to under root Rg, alpha is equal to R by Z0, alpha is equal to G into Z0, alpha is equal to R upon R into C by L, and G into L by C. Yes sir. So and Z0 is equal to 1 by RG and L by C. Yes sir. So they are asking the question alpha. They are asking the value of alpha. Why it is lossy? Because R is non-zero and distortionless it is given. Distortionless it is given in the question. So what is the value of alpha? So alpha will be R upon Z0. R we know that 0.1, Z0 we know that 50, so it will be 0.002 and unit is Nepper per meter. Unit is Nepper per meter. So 0.002, that means our answer will be C. Our answer will be C. It is a very easy question, formula based question. A transmission line has characteristic impedance. Characteristic impedance and load impedance is given. Characteristic impedance is 50 ohm. Load impedance is 50 ohm. Okay, sir. Then you have sinusoidal voltage source. Frequency it is given 10 gigahertz. 10 gigahertz yani 10 to the power 10 hertz. And the phase difference. And the phase difference it is given. What is the phase difference between 2 points? So distance is given. That means 2 mm. 2 into 10 to the power minus 3 meter. Then they have given phase difference. Phase difference we know that beta d. Beta d is equal to pi by 4. They are asking phase velocity. Phase velocity will be equal to what? So beta we know that beta is equal to what? So pi by 4 and divided by d yani 2 into 10 to the power minus 3. So minus 3 it will be plus 3 and unit will be radian per meter. Then we have what? BP. BP is equal to omega by beta. Omega 2 pi f. F is 10 to the power 10 and beta is pi by 8 into 10 to the power 3. So pi will be cancelled out. So our answer will be 16 into 10 to the power 7 meter per second. Yani 1.6 into 10 to the power 7, 10 to the power 8 meter per second. Our answer will be C. Very easy question. Just we have to apply this phase constant formula and we should know the phase velocity formula. If you know the formula for phase velocity, if you know the formula of phase constant, phase shift, so you can also find out phase velocity. It is a very easy task. Then what I have told you that all distortionless are, all distortionless are. So distortionless case there is two types. One is lossy and distortionless is lossless. Yes sir. So all lossless are distortionless, but all distortionless are not lossless. Means I have taken distortionless. I have taken distortionless, and I will take lossless also. I will take lossless. So lossless will be sub part of distortionless. So this is lossless. This is lossless. So our lossless, we know that this is lossless. In case of lossless, alpha is equal to 0. And this one is lossy. In case of lossy, alpha is not equal to 0. Yes sir. And in case of lossless, what is the formula of Z0? In case of lossless, formula for Z0 is under root L by C. And in case of distortionless, lossless plus distortionless, lossless plus distortionless, and lossy plus distortionless, lossy plus distortionless, what it will be? In this case, Z0 is equal to under root L by C under root r by g. Yes sir. So now we can solve the problem what they are saying. It is already started Hertzing. You can go through that. You can go through that this channel. It is already started. Transmission line whose characteristic impedance is pure resistance. So transmission line whose characteristic impedance is pure resistance. Yes, it is pure resistance. So pure resistance, what is the answer? What is the answer? Then transmission line will be, so must be a lossless transmission line. Must be a lossless, it may be lossy. So must be a lossless is wrong thing, because it may be lossy, it may be losses. So it may be lossy or it may be losses. So our answer will be wrong. Must be a distortionless. Yes. Must be a distortionless. Yes, it is a correct. So answer B is correct. May not be a lossless. Yes, may not be a lossless. It may be lossless, or it may be lossy. So it may not be lossless, it may not be lossy. So this one is also correct. May not be a distortionless. No, it is surely distortionless. So this is wrong. So our answer will be, it may be, must be distortionless, but it may be lossless or distortionless. So may not be lossless is better option. So our best option will be distortionless transmission line. So which option in case of MCQ? I will give B option, and in case of MSQ I will give B and C option. In case of multiple choice question I will give B option. In case of multiple select question I will give B and C answer. Okay. Then in air, that lossless transmission line is 50 centimeter length, L is given, C is given. They are asking electrical parameter, electrical length, electrical path length. So we have given length is equal to 50 centimeter. In case of meter, it is 0.5 meter. L is given how much? 10 microhenry per meter. That means 10 into 10 to the power minus 6 Henry per meter. Capacitance is given 40 picofarad. Pico is 10 to the power minus 12, so farad per meter. Frequency is 25 megahertz. That means 25 into 6 hertz. What is electrical length? Electrical path length is what is electrical path length? Beta L. In previous class you have studied, in case of beta L, because of beta L the short circuit is inductive, capacitive, short circuit, open circuit. Because of beta L the open circuit is inductive, capacitive, open circuit, short circuit. So we know beta L will be the deciding factor for characteristic impedance or anything. So beta L is known as electrical length. You can note it down in your notebook that beta L is the electrical length. So beta is how much? Beta is omega under root LC into L. We know L's omega, LC, everything, so we can calculate. So omega is 2 pi f. F is 25 megahertz, and that means 25 into 10 to the power minus 6. So 2 pi 25 into 10 to the power 6. This is omega. L is 10 into 10 to the power minus 6 and 40 into 10 to the power minus 12. And length is 0.5. So it will be 50. That means 50 pi. Yes sir. 10 400. 400 under root is 20. 10 to the power minus 18 root is 10 to the power minus 9 and 10 to the power 6, so plus 6 and 0.5, that means 1 by 2. So 2 will be cancelled out. So our answer will be 2 will be cancel out. So our answer will be our answer will be 6 minus 3. So minus 3 and 100. So 10 to the power minus 8. So it is 0.1 pi. 0.1 pi. That means pi by 10. Pi by 10. That means pi by 10. So our answer will be pi by 10. Pi by 2 is coming. Okay, 50 is there. Okay, so 50 is there. The 5 pi by 10. 5 pi by 10. So 5 pi by 10 is pi by 2. So answer is pi by 2. So electrical path length is our beta L. I will take class in 2 minutes. Okay, so a coaxial cable with inner diameter 1 mm, outer diameter 2.4 mm and dielectric of relative permittivity 10.89. Mu is something like this. Epsilon naught it is given. Characteristic impedance of the cable is. So it is a coaxial cable. It is a coaxial cable. In case of coaxial cable, L is equal to mu by 2 pi ln b by a. Yes sir. In case of coaxial cable, capacitance per unit length is 2 pi epsilon ln b by a. Yes sir. Then we have a inner diameter. Inner diameter means 2a. 2a is 1 mm and outer diameter 2b is 2.4 mm. So we know the value of A, we know the value of B, because this is our coaxial cable. Yes sir. This is our coaxial cable. Yes sir. And this is our inner diameter. So this inner diameter has radius A and this outer diameter has a radius B. So inner has radius B, so diameter is 2A. Outer has radius 2B, so outer is 2B. So inner diameter is 2A, outer diameter is 2B. Then we know the formula of Z0. Before that, we will calculate the value of mu epsilon. Mu epsilon is mu naught into epsilon naught, mu naught into mu r and epsilon naught into epsilon r. Yes sir. Mu naught into epsilon naught, mu naught value is 4 pi into 10 to the power minus 7 and epsilon naught is 1 by 36 pi into 10 to the power minus 9. It is given 4 pi into 10 to the power minus 7, 1 by 36 pi into 10 to the power minus 9. And mu r, we know that, mu epsilon r, we know that. So it is 4 pi under root is 2 pi and 36 under root is 6 and 10 to the power 900. So mu r into epsilon r. So it will be 120 pi under root mu r into epsilon r. So this is the value of mu by epsilon. Then we know the value of Z0. Z0 is equal to under root L by C. I'll put the value of L, mu by 2 pi ln b by a, and second thing is 2 pi epsilon ln d by r. Yes sir. So what we will do here, it will be mu by epsilon divided by 2 pi ln b by a. Yes sir. Mu by epsilon is 120 pi under root mu r epsilon r and divided by 2 pi ln B by A. So I'll put the formula and I will get the answer 60 mu r epsilon r ln V by A. Okay. So mu r is not given. So I will take 1. Epsilon r is 10.89. Epsilon r is 10.89. 60. Mu r is not given. I will take 1. 10.89 ln. Value of B will be, so value of B will be 2.4 divided by 2, 1.22, 1.2 and 1 divided by 2, so 0.5. So 1.2 B and A is 0.5, 2.4. So I will calculate the value of this, the value of this transmission line, characteristic impedance. So 10.89 under root 10.89. It will be 3.3, 60 divided by 3.3 ln 2.4. So 2.4 into 18.18, 60 divided by 3.3, 15.9, 15.9 ohm, 92 ohm. So this is the value of Z naught. It is a very easy point. ln B by A, sorry, here ln B by A. So it is a very easy question. You can solve this. So our answer will be 15.92. D is the answer. Then we have a question that, what we have a question, a parallel plate transmission line, V is the speed of propagation, Z is the characteristic impedance. So parallel plate transmission line. What is parallel plate transmission line? So in case of parallel plate transmission line, we have the formula of capacitance W epsilon upon D, and we have the formula of L mu D by W. Yes sir, this is our parallel plate transmission line. This is our parallel plate transmission line. Yes sir. So we have a spacing between them is D, we have width W, and we have length L. Then we will go for VP. VPV is equal to 1 root LC. I will multiply L and C. I will get mu epsilon. Okay. Then for Z naught. For Z naught, it will be under root L by C. So L by C, it will be mu by epsilon D by W. Mu by epsilon D by W. So this is the formula for Z naught. This is the formula for VP. Yes sir. Now what is the question in this point? So Z is the characteristic impedance, neglecting fringing effect, reduction of a spacing between the plates by a factor of 2. So factor of 2, a spacing between the plates will be decreased. So a spacing between the plates is decreased by D by 2. So if a spacing between the plates is decreased by D by 2, there is no change in phase velocity. Why? Because it does not depends upon D. And here there is change in characteristic impedance because Z naught is directly proportional to D. So in case of Z naught is directly proportional to D. That means Z naught will be changes to Z naught by 2. Yes sir. And VP is independent of D, so VP will be remain same. So VP will be remain same. Z naught will change. Z naught will be Z naught by 2. Half in VP, no, wrong. No change in Z, this one is also wrong. No change in VP, correct. Half in Z naught, correct. So our answer is B. No change in both VP and Z. So VP is Z, there is a change. Half in VP and Z, So this is wrong. So our answer is C is wrong, D is wrong, A is wrong. So our answer will be B. Our answer will be B. It is a very easy question. This question is asked in GATE exam. Characteristic impedance they are asking. This question asking is ESC. So in ESC exam they have asked this question. They have given L, they have given C, they are asking Z0. So Z0 is equal to under root L by C. L is how much? 0.294 microhenry, that means 10 to the power minus 6. Just figure it out, what is the value of the value in SI format. Then it is very easy to calculate. So 294 divided by 60 into 10 to the power 3 into 10 to the power 3. So it will be 100. So 294 divided by 6 into 10 to the power 2, 10. Then 6, yes sir, 2, 3, and this 2, 1, and 9, 4. So 2, in case of 2, 4, 7. Then I will divide with 3. So it will be, in case of 3, it will be 49. So our answer is 49 into 10, that means 70 ohm. That means 70 ohm. That means our answer will be C. This is also a good question. This is also a good question. What is the question they have asked? For a transmission line with homogeneous dielectric, the capacitance per unit length is C, relative permeability is R, epsilon R, velocity of light in free space is B, and characteristic impedance Z0 will be equal to. Characteristic impedance Z0 will be equal to. Okay. So capacitance is equal to, so Vp is equal to, you will say Vp is equal to, so Vp is equal to 1 by under root LC, and it is also C0 under root mu r epsilon r. Mu r is not given, so I will take C0 under root mu r epsilon r. Because mu r is not given, I will take mu r is equal to 1. So this is our Vp. Z0 is equal to 1 by under root LC. 1 by under root LC. Yes. So if I will multiply this, what I will get? So if I will multiply this, so Vp into Z0 will be equal to, Vp into Z0 is equal to 1 by C. So Vp Z0 is equal to Vp, Z0 is equal to Vp 1 by Vp into C. Vp is equal to C0, and C0 is given as a small v under root epsilon r. So it will be given as under root epsilon r, a small v into P, v into C, a small v into C. So our answer will be C option. I have put the value of this one. So what I have done? I have multiplied this one and this one. So multiplied this one, we will get this. Yes. After that, what I have done? I have used V upon epsilon r. So here I have used V upon under root epsilon r. So in that case, I will calculate Z0. So Z0 is equal to under root epsilon r V upon C. So alpha is for distortionless transmission line. That means it may be lossless or lossy, but it is saying distortionless, so I will take lossy. by default I will take lossy. So lossy plus distortionless. What is the answer for lossy plus distortionless? So lossy plus distortionless is, what is the answer? So alpha is equal to under root Rg, R by Z naught, G into Z naught, and second thing, R upon C by L, G into L by C. Yes sir. Then the formula will be R into C by L, under root C by L. So answer will be C, B. A option is also correct. A option is also correct. So this is best, this is better, this is best, this is better. So alpha is equal to 0. It is lossless plus distortionless. Lossless plus distortionless. So our answer will be, in that case, alpha is equal to 0. So our answer, best option will be B. 50 ohm transmission line, characteristic impedance is given. Inductance they are asking. So Z0 is 50 ohm. Characteristic impedance C is equal to 10 to the power minus 10 farad per meter. They are asking L. So Z0 is equal to under root L by C. L is equal to Z0 square into C. Z0 is 50, so 50 ka square into 10 to the power minus 10. That means 25 into 10 to the power minus 8 Henry per meter. If I will write in microhenry, 0.25 microhenry per meter. So 0.25 microhenry per meter. So our answer will be A. Our answer will be A. Next question. Next question is this one. 1 second. So in this question, what we have given? They have given a lossy transmission line, yes, whose alpha is equal to 5, beta is equal to 5. So alpha is how much? 2, beta is how much? 5. That means gamma is given 2 plus J5 per meter. Yes sir. Then Z0 is given 50 ohm. Yes sir. And omega is given 10 to the power 6 radian per second. Radian per second. Then they are asking RLGC value. Okay. So first of all, omega is 10 to the power 6 radian per second. Gamma is equal to 2 plus J5 per meter. And Z0 is equal to 50 ohm. So since alpha is non-zero, so we have to think alpha is equal to not equal to 0. That means it is lossy. Okay. So in case of lossy and distortionless, you know the formula. Why it is distortionless? Because Z0 is real. Z0 is real. So I will write something. You should have to remember that thing. First point is, if alpha is 0, Z0 is real, then that is the case for lossless and distortionless. Yes sir. Distortionless. Distortionless. Okay. Then alpha is non-zero and Z0 is real. Then this is the case for lossy and distortionless. Lossy and distortionless. Always try to remember this point. And alpha is non-zero and Z0 is complex. Z0 is complex. So this is lossy and distortive. Lossy and distortive. And alpha is 0, Z0 is equal to complex. Not possible. Not possible. This is not possible. So this is the things which you have to remember the points. These are the points which you have to remember. Okay. So these are the points. So here what we have? We have alpha. We have alpha is non-zero and Z0 is real. Alpha is non-zero and Z0 is real. That means alpha is equal to non-zero and Z0 is real. That means it is lossy and distortionless. Lossy and distortionless. Sir, how you know that? If both are same in lossless and distortionless, you have derived this Z0 is equal to under root L by C. This Z0 is equal to under root R by G and under root L by C, and this Z0 is equal to under root R plus J omega L G plus J omega C. Yes sir. And this Z0 is equal to R plus J omega L G plus J omega C. Yes sir. So I will ask, if it is real, then it is lossy and distortionless or lossless or distortionless. Depends upon alpha. Alpha 0, lossless. Alpha non-zero, distortionless. Z0 real, distortionless. Z0 real, distortionless. So alpha 0, lossless. Alpha non-zero, lossy. Z0 real, Z distortionless. Like that you have to know. Alpha is non-zero and it's complex. Yes, it is lossy and it is distortive. But in case of alpha 0, if alpha is 0, then R or G will be 0. If R or G will be 0, then it should be real. So if alpha is 0, Z0 should be real. So alpha is 0, Z0 should be real, which is not here written. So we know that this is not possible. This is lossy plus distortionless. Yes sir. So in case of lossy plus distortionless is R into G, R by Z0, G into Z0. Yes sir. So R will be equal to alpha by Z0, alpha into Z0. Yes sir. And G is equal to Z0 upon alpha, alpha upon Z0. Yes. So alpha is how much? 2. Z0 is 50. So 2 into 50, 100 ohm. 100 ohm. Alpha by Z0, alpha is 2. It is 50. So it should be 2 by 5. So 200. 2 into 20 divided by 1000. So it is milli-Simon per meter. Because I am saying it is, I am multiplying with 20 and divide by 1000. So it will be 0.400 divided by 1000. 400 divided by 1000. So it will be 0.4 milli-Simon per meter. Milli-Simon per meter. This is 100 ohm per meter. So 0.4 milli-Simon per meter. So this is 0.4 Simon per meter. That means 400 milli-Simon per meter. Yes sir. So by using this formula we have derived, so R is equal to alpha into Z naught and G is equal to alpha by Z naught. So we have derived. So alpha R is equal to, what is the value of R here? R is 50, no, wrong. R is 100, correct. R is 100, correct. R is 50, wrong. R is 0.02, wrong. R is 0.04, correct. R is 0.02, wrong. And R is 0.04, correct. So our answer will be, answer will be B. Answer will be B. So B will be the answer. B will be the answer. So 0.04 Simon per meter. So from R and G you can find out. From R and G you can find out. 50 ohm, 100 ohm, 100 ohm. So 100 ohm, this B and C will be correct. In case of B and C, B is correct. In case of B and C, B is correct. Then we will calculate L and C. Then we will calculate L and C. So beta is equal to omega under root LC. It is equal to 5. So under root LC is equal to 5 by omega. Omega is 10 to the power 6. So 10 to the power minus 6. Z naught is equal to under root L by C, which is equal to 50. So I will multiply these two. So Z naught into under root L by C is equal to L. Z naught under root L by C is equal to L. So L is equal to 5 into 10 to the power minus 6 into 50. That means 250 microhenry per meter. Then we have under root LC divided by Z naught is equal to C. So C is equal to 5 into 10 to the power minus 6 and divided by 50.1 microfarad per meter. So our L is, C is 0.1 microfarad per meter. L is 250 microhenry per meter. L is 250 microhenry per meter. So our answer will be 250 microhenry per meter and 0.1 microfarad per meter. So L, C, R, G we have calculated. So it is a very easy question. In this case, condition for transmission line to be lossless, low loss. So in case of low loss, R should be minimum. So R should be less than omega L and G should be less than omega C, because this is the condition for low loss. R should be lower and G should be lower. So R should be less than omega L and G should be less than, greater than, wrong, less than, correct, greater than, wrong, less than, correct. So our answer will be C. R should be less than, R should be minimum and G should be minimum. R is given, Z naught is given, alpha this is asking. So alpha is equal to R by Z naught. So R we know that 0.05 and Z naught we know that 50. So it is 0.001 Nepar per meter. Up to 3 decimal places. So answer will be 0.001. 0.001. Absolute value of attenuation they are asking. So this is a different question. You have to analyze. So I will write what is VL. VL comma T is written as e to the power minus gamma L e to the power j omega T. So e to the power minus alpha L e to the power j omega T minus beta L, j omega T minus beta L. Then I will ask what is the magnitude of VL comma T. So you will say it will be e to the power minus alpha L. So I will ask, what is the value of, so they are asking per unit length. So this is the loss, this value will be decreases. This is the attenuation factor, this is known as attenuation factor. You will study in where? Skin depth. In electromagnetic wave you will study this. So this is attenuation factor. So loss is equal to minus, it is voltage, so 20 log 10 attenuation factor. So why it is minus? Because it is a loss, so minus. It is voltage, so I use 20 and 10 log attenuation factor because this one is decreasing. So minus 20 log 10 e to the power minus alpha L. So it will be 20 alpha L log with base 10 e. Then I will solve, I will get 8.686 into alpha L. This is the loss. Then they have asked loss or attenuation in meter. So it is in dB. So loss per meter, it will be 8.686 into alpha. This is loss per meter and alpha is 0.1. So 8.686 into 0.1, it will be 0.8686 dB per meter. So this is our loss per unit length. List 1, list 2, Z is equal to R plus J omega L, Y is equal to G plus J omega C. Okay. Characteristic impedance. So characteristic impedance is equal to R plus J omega L divided by G plus J omega C. Yes sir. So it is Z by Y. So Z by Y is 2. So our answer will be 2. So for A, 2 option. Propagation constant is equal to under root R plus J omega L and G plus J omega C. So it is nothing but what it will be? Under root Z into Y. Z into Y first. So our answer will be first. Second, they are asking characteristic impedance. So characteristic impedance is Z by Y. So it is second. First, second is the matching. So second, first, second is the matching. Second, first, second is C option is correct. Which option is correct? C option is correct. So in next class we will study that short circuit transmission line and open circuit transmission line and resonance condition, the question discussion. So yesterday class topic question discussion will be on Monday. There is no class on Saturday and Sunday. Okay, so we will meet in Monday and we will discuss lossless and distortionless transmission line question. Sorry, we will discuss which part? Short circuit and open circuit transmission line question. Okay, so our class will be over today. First point, you have to note that there is a question discussion. Which topic question discussion? So question discussion topic is lossless and distortionless transmission line. Lossless plus lossy. So our question discussion is in basic part of transmission line. Basic of transmission line. So basic of transmission line, our question discussion is there. And tomorrow and on Monday class there is a question discussion on which part? Short circuit and open circuit question discussion. Okay, and I will go through the question discussion for short circuit and open circuit. You can pause the video and you can solve this question. So I will go through the question. I will go through the question one time so that you can solve first previously and then come after that. So I will do this question in a slow manner so that you can read it perfectly. You can read it perfectly. 1 second. So you can read it. This is a very easy question. This is a very easy question. So lossless transmission line. First question you will read. Second question you can pause the video and you can read this question and solve this question and come in the next class. On Monday class we will discuss this question. On Monday class I will discuss this question. This is question number 3. I have written in the corner. And this is question number 4. I have written in the corner. So I have to ask lossless, lossy, lossless, lossy transmission line question discussion. Then ZOC, ZSC is given. Z0 they are asking. ZOC, ZSC is given. Z0 they are asking. This is question number 6. It is repeated question, so I will delete it. It is a repeated question, so I will delete it. This is question number 6. This is question number 6. This is question number 7. You can go through the question number 7. You can go through the question number 8. Pause the video, solve the question and come in the Monday class. I will discuss. Question number 9. Yes sir. This is question number 10. You can pause the video and solve this question. This is question number 11. This is 11 number question point. Okay. This is question number 12. This is question number 13. This is question number 14. 15 and 16 and 17 and 18. Which question? 18. 19. 20. 21. 22. 23. 24. 25. 26. 26 questions are there. So in tomorrow class we will discuss 26 questions. This is Unity app. You can download and you can go through the models: interactive poll, 3D model library, live classes, notes and doubts, YouTube notification, and dashboard leaderboard and video call. So you can download this app. You can get live classes note also. So you can get the notes from this app. Okay, this is our this is a very good thing that there is a doubt in this session. By using this app, you can connect me at from Sonu Sir PW Telegram group. Thank you.